In the previous video, we have set up all the boundary conditions, and once again I just want to repeat the boundary conditions. What I'm assigning for the case are based on my own assumptions with respect to the velocity, the species, etc. Obviously the air will be having 0.23 mass fraction of oxygen, that is default, but with respect to fire, carbon dioxide point of view, I'm just assuming, and also the velocity, the temperatures of the fire and the oncoming air, I'm just assuming it. Okay, so we are kind of performing a conceptual study and seeing whether we are able to simulate that case or no, right? So now the next option or the next task for us is to deal with the operating conditions. Now in one of my previous videos I have clearly explained what is, I'm sorry, not the previous video, the previous course I can say, or some other course of ANSYS which I have, the CFD course. In that I've clearly explained about the operating pressures, right? So we cannot discuss much detail about it again, but in ANSYS Fluent, to be to understand as a simple note, what we can understand is in ANSYS Fluent, the software or the solver avoids the problem of round off errors. Okay, and it is a kind of problem that will restrict you to solve the case. So in that way, in order to avoid the round of error, the software is subtracting the operating pressure from the absolute pressure and using the result of that particular case or that particular value as the gauge pressure, right? So the absolute pressure is simply the sum of operating pressure and the gauge pressure, right? So what we are entering is operating pressure in this particular operating conditions, and that is how we are dealing with the round of errors in ANSYS Fluent. Clear? This may be a bit confusing, but just try to catch up. And in operating conditions, we basically have two things. The first thing will be operating pressure. Like if we are assuming that this case is at sea level, so we can just enter the value of operating pressure. Okay, that is 1/325. Now we have another two things, that is operating temperature and operating density. Now coming to operating temperature, this is basically used when we are using some other density model named as Boussinesq or Boussinesq. I don't know what do we call it, but we have this. I'll just show you over here. For example, if you are going to materials, fluid, air, if we are changing the density of air to Boussinesq or Boussinesq, okay, this is a quite confusing name actually. So in that cases, we have to be bothered about the operating temperature, but right now we are not using that thing, so we can just ignore things. So we can just, it has no meaning in this particular simulation. Now coming to operating density, so this is also a specific value which we have to enter to avoid the round off errors, we can say, right? So for simulations where there are pressure boundary conditions, and in this cases it is important to set the value correctly for the operating density. Clear? So that is a little bit important. And here we have this we have to set the density value. Now what is the density value we must set over here? Now what do we need to do is we need to go to reference values, and in reference value we just need to click on, by default you can see the density is 1.225, but when we are going to compute from inlet, the software will calculate some reference values, and you can see the density is 1.995077, right? So I'll just copy this one and go to operating conditions in the boundary. This is already open over here. Click over here and paste the value over here, right? So this is how you have to deal with the operating density as well. Clear? So I'll just repeat again. In ANSYS Fluent, the problems of round of error exist. So what the software is programmed is, the software is programmed in a way that the subtraction of operating pressure from the absolute pressure will be used as the result, and that is termed as the gauge pressure. Clear? So I'll just press OK over here, and we have the operating density set and all the respected values over here.